welcoming Courtney LeBoeuf.
Thank you. Wow, I haven't been described as fun-loving in quite a while, so that's very nice, Yuki. Thanks. Well, welcome here this morning, this wonderful group of young ladies out here. I want to thank you for being here so early on a Saturday morning. I know you could be doing countless other things, texting your friends or playing on Facebook or whatever it is that you do on a Saturday morning. But instead, you came here and you chose to expand your horizons by learning about careers in math and science. And so just by being here, just by showing up today, you are already bettering yourselves, and I congratulate you for that. You may be wondering why there is a lawyer up here talking to you at a science and math event. That's a really good question, and I'll get to that in a few minutes. But before I do, my slide didn't change, did it? There we go. Before I do, I just want to, by a show of hands, want to know of this audience, how many of you know exactly what you want to be when you grow up? I mean exactly. And I'm going to call on you if you raise your hand. Yes. What do you want to be?
I want to travel the world and write about genetics.
Travel the world and write about genetics. Wow. Can I come with you? That sounds like fun. Who else knows exactly what they want to do? Precisely. Yes, in the red jacket.
I want to be an architect.
She wants to be an architect. Wonderful, wonderful. And we'll take one more over here from somebody who knows exactly what they want to do. Yes, blue sweatshirt. Personal trainer. And right next to you?
Marine biologist.
Personal trainer and a marine biologist. Well, a lot of these careers are science-based. That's wonderful that you are here. But I know that a lot of you do not know what you want to do. Is there anyone here in the audience who has just kind of a general idea about what they want to do? Maybe the general field, or they know areas that they're interested and they kind of like, but not necessarily, they don't know the exact job. What about you?
I was thinking about being a piano teacher.
Piano teacher, okay, wonderful. Yes, and you? Into the science field, okay, so a general sense of science, music, specifically piano, and what about you? A veterinarian. Good. So a lot of you have done a lot of thinking about this, I see. And now it's time to ask, how many of you have absolutely no idea what you want to be when you grow up? Yep. It's okay. There's no shame in that. And that's probably part of the reason why you decided to come here this morning, I imagine, is that you think maybe science, maybe math, I don't know, I'm here to check it out. And that's what today is about. And so I congratulate you all for being here. For those of you who know specifically what you want to be, this is a great opportunity for you to enhance your knowledge about what you already know. And for those of you who think you kind of know, again, this is an opportunity to ask questions and maybe kind of narrow your focus a little bit. And for those of you who know exactly what you want to do, have any of you ever thought about what would happen if you went to school to become that particular job, and all through high school you focused on your science and your math, you go to college and you pick your major for that job, and you get out into the real world, you get your job, and on day 2 you realize, I hate this. This is boring. What do you think you would do? Besides freak out. Yeah, what do you think you would do?
Give it another chance.
Give it another chance, yeah, that's a great idea. What about you?
Quit, study again, and go into a different field.
Quit, study again, and go into a different field, yeah. Well, the scenario that I described actually happened to me. So it's not always the case that you have this ideal job that you think you want, and then you get it and life's perfect and you go on with that job and it's great. Oftentimes it happens that you make your way through your education and you realize you don't really want to be that thing. And so that's part of the message of my speech, is to expand your horizons about what else you can do with a science degree or a math degree, because there are a lot of non-traditional jobs in those fields. Who knows who this woman is? Anybody? Come on, somebody's got to know. Way back there. What did you say? Yes, Jane Goodall, exactly. Jane Goodall is a British primatologist and anthropologist, and she's also known as the world's foremost expert on chimpanzees. And when Jane was 26, she was motivated by her love of animals, and she left her home in England, traveling to Africa to study the social and family interactions of a family of chimpanzees in Tanzania. Now, when I was a little girl, I wanted to be Jane Goodall. I wanted to go traipsing through the jungles of Africa studying chimpanzees. I thought it would be just such an exciting adventure, and I'd have such an exotic life, and it just sounded very romantic. So that's kind of what my goal was going through school. When I was in junior high school, I took just the general science classes that you take, and when I got to high school, I took advanced placement biology and just learned as much as I could about animals. And then when I went to UC Davis for college, I majored in environmental biology because I wanted kind of a broader understanding of biological systems in the world around us. And I also chose that major because they had a really cool study abroad program where you could actually go to Costa Rica to study in the rainforest. And I thought, oh, Jane would do that. She had the opportunity. So of course, following in the footsteps of my hero, I made my way to Costa Rica to do this tropical biology program. And the most exciting part of the program was that we actually got to do field research. So I thought, this is my Jane Goodall moment. I'm going to get to study, they don't have chimps in Costa Rica, but they have monkeys. I'm going to get to study monkeys and be a primatologist, and this is going to be great. And I told my professor my idea for my research project, and he said, now you realize you only have 2 weeks to collect your data and analyze your results and write a paper and prepare a presentation. I said, yeah. And he said, Jane Goodall's been doing this for decades, right? You're probably not going to find anything significant about the monkeys in 2 weeks, so you may want to reconsider. But that didn't deter me until I went out on my first scouting data collecting mission to actually try to find monkeys. And you can probably see it there, but monkeys are very difficult to find. Who knows why monkeys are hard to find? Yeah. Yeah, they're in the trees. And what do they do in the trees?
Hide, run away.
How do they hide specifically? Do you know? Yeah. Camouflage, yeah. Monkeys are great camouflagers. So unless you're very patient, which I'm not, unfortunately, it's really hard to find the monkeys. And do you think monkeys stick to the trails that humans have created? No, they go deep into the jungle. And so my professor reminded me, he said, if you think you want to study monkeys, you better be prepared to get a machete and start hacking your way through the jungle. Whoops. So there's me in a tree. As I decided not to do the monkey project because I didn't feel comfortable hacking my way with a big machete through the jungle, and didn't know if I'd be able to find monkeys after all of that. So instead, I picked an easier topic. There was this tree right by the dorms that we were staying in Costa Rica, and I decided to study bees. There's a big bee's nest in this tree, and they were stingless bees, which was even better. And so that's what I did for my research project in Costa Rica. And for 2 weeks, I had these bees all to myself. I sat up in this tree collecting bee data. I watched the bees go in and out of the nest all day, every day, for about 10 hours. I collected pollen samples, and the first couple of days I thought it was really neat. I'd look around and look where I am. I'm in this amazing jungle in Costa Rica, and all my friends are at home in Davis studying at the library, but I get to be here. So I really enjoyed it at first. And then day 4, day 5, day 6, I started to get a little bored. I don't even know if you know what Walkmans are, but I had one because we didn't have the iPods back then. And I got sick of listening to the 4 tapes that I brought with me. And just really began to question, is this what I want to do? The best part of my day was when I got to go to the lab to analyze my pollen samples. And that was the best part of my day because that's where all my friends were. They were in the lab hanging out, and so I got to talk with them and just kind of talk about how our projects were going. So from there, I decided that I was not going to be the next Jane Goodall. I am entirely too social of a person that a life of a field biologist is a wonderful career, but not the career that's meant for me and my personality because I like to be around people. I thought long and hard about what I could do with my biology background and my interests and working with people. And I'd remembered this kind of cheesy movie that I saw a few years back before she was Erin Brockovich. Julia Roberts started a movie called The Pelican Brief. Did anybody here see that? Yeah, I think you were probably really little when it came out. Anyway, it's an interesting movie, but in the movie, Julia Roberts plays this law student who goes to Tulane, incidentally, and she gets involved in this conspiracy involving an oil company trying to take back some land that had been protected to save a brown pelican. And there's car chases and murders and all that kind of stuff. That's not exactly what I thought my career would be like, and I wasn't hoping it would be like that. But that movie just kind of gave me the idea of the practice of environmental law. Here's a career where you can have a background in environmental sciences, which I have, and law school doesn't require any prerequisites the way other graduate programs do. So I did my research, and after law school, I actually ended up following in Julia Roberts' character's footsteps, and I did go to Tulane University, not because she did, but because once I did my research and realized what colleges in the US had the best environmental law programs, Tulane came up on top, not to mention the fact that it's in New Orleans, which is a really fun place to be. So after 4 years at Davis and 3 years at Tulane, I was on my way. I finally had my degree and was all set to practice environmental law. And that's what I did, and that's what I'm currently doing. I work at a law firm in San Francisco called the Edgecombe Law Group, and we practice solely environmental law. And I'll tell you a little bit more about my practice. I'll be brief because I also want to give you some examples. Not everyone here I know is interested in becoming an environmental lawyer, and so I really want to try and offer you a broad spectrum of careers that you can have with a degree in science and math that you may not have thought about yet. So briefly, one of the things I do in my job is I work with hazardous waste, not personally, like with the big suits and everything, but I work with hazardous waste issues. And just to give you a brief backstory, how many of you have heard of a law called Superfund or a Superfund site? Has anybody heard of that? In the 1960s, there was a neighborhood near Niagara Falls, New York called Love Canal, and I'm sure your parents will remember this, although you may not. And in Love Canal, something happened there called a cancer cluster. And what that is epidemiologists, those are scientists who study the spread and progression of diseases. They noticed that quite a lot of people in this community were coming down with all kinds of cancers and illnesses and asthmas, babies were having birth defects, and it was not a normal amount that you would normally see in the population. It was heavily concentrated in this one neighborhood. And after research revealed that it was built on a toxic dump site, Congress and the American people got really mad. How could we do this? How could we build a school for our children on a toxic site? How could we let them drink this water and have these things happen to them? And so they passed this law in 1980 called Superfund, and it's a really significant law because it means that it is illegal to pollute, to dump any sort of hazardous waste. But it goes even further than that. It's not only illegal, but if you or your company disposed of hazardous waste even before the law existed, you're still responsible for going and cleaning it up. And if you want to purchase real estate and that piece of land is contaminated, you then become responsible for cleaning it up. So it's what's known as a strict liability law. So what I do is I help companies, some companies want to purchase properties and don't want them contaminated, or sometimes they do want contaminated properties because they're cheap and they want to clean them up. And so I'm very lucky in that I get to work with scientists, soil scientists, hydrologists, and we figure out how to clean up these properties. I also get to work with government agencies like the Department of Toxic Substance Control and the EPA, you may have heard of, because they set all of the regulations, and I help my clients being compliant with all of those regulations. So that's a lot of fun. I really enjoy that work. I'm glad I have some chemistry background because I often find myself looking at tables of calculations, and math comes in handy for me too when I need to look and see, I'll look at a water report and see, and then I'll look at the law and I have to decide, does this report meet this law? And sometimes that's, I have to do math conversions in my head. So for that reason, I'm really glad that I have this strong background in math and science. I'll just tell you about one other thing that I do that I really enjoy is I work for some land trusts. And what land trusts do is they preserve and protect open spaces for species, for habitat for species. Not necessarily just for that, they also work to protect farmland. You live in the Central Valley, so you know, as I do, since I grew up here, that there's a lot of threats from development. As we build more and more, we have less and less space for agriculture use and habitats for animals. So what organizations like land trusts do is they buy up all this undeveloped land and they put it in what's called an easement, which means that it's just protected for all time. And so I find that really rewarding, knowing not only that I'm helping clean up toxic waste, but I'm also helping these organizations preserve land for the future. I'll give you an opportunity to ask a few questions. So you might have heard of a lot of the traditional science and math careers, such as an astronaut, engineer, doctor, teacher, chemist. I lost my place on my notes because I wasn't using my notes. So these are, just to name a few careers that you probably have heard of. But there's probably a lot you can do with a science degree that maybe you never have heard of. One example I always like to give is being a science writer. Every major newspaper, from the San Francisco Chronicle to the New York Times to the Washington Post, they all have science writers. Magazines, the weekly news magazines such as Time and Newsweek have science writers. And textbooks, you all have science textbooks, right? Yeah, mostly. Someone has to write those. And it's a lot better if somebody who knows about science is writing about science. And textbooks are written at all levels, from junior high, all the way up to college. So that's one example of something you can do with your science or math degree. For those of you who are artistically inclined, what? Okay. So for those of you who are artistically inclined, you can think about a career as a science artist. And everybody laughs at this one, but it's true. TV consultants. I have friends who are screenwriters, and they tell me these shows, such as Grey's Anatomy and CSI, they employ people with science backgrounds to make sure that they are telling a true story, to make sure the technology is real and that the dialogue is accurate. And finally, organizations such as the National Science Foundation, the National Institute of Health, they employ science background people to help them with their grants programs. They have lots of jobs available to people with science backgrounds, as well as the government. Park rangers, park interpreters, people working for the EPA, the World Health Organization, and the FDA are just a couple examples. And I just want to leave you with a quote from one of my mentors, Miss Jane Goodall. Every individual matters. Every individual has a role to play. Every individual makes a difference. And know just by being here today, you all have made a difference because you've bettered yourself. So I congratulate you for that and thank you for your time.